Greetings everyone, I am Dhruv Shaw from LP Jalandhar. My research is on the topic robotic swarm with the independent selection of master and slave configuration. So the agenda for the today's presentation is the introduction, where we would be doing the literature review of what is swarm robotics, then the motivation, then the proposed approach which I am proposing, then its advantages and application, then the challenges which I faced, and the future work what I am planning in the long term to do with this research topic, and the conclusion, the main gist. So the introduction. Let's talk about what is swarm robotics. Swarm robotics is mainly the implementation of swarm intelligence. Swarm intelligence is artificial intelligence technique and is mainly inspired by the nature and the biological organisms, where we study nature and biological organisms movement and derive a mathematical equation, and which would be actually applied in our robots, and the main goal is to reduce workload and the increase efficiency of the system, also known as the collective intelligence. So what's the problem with the current approach in the swarm robots? The main problem is the lack of understanding of the behavioral pattern of swarm, the task allocation, because since there are a lot of different robots, and a lot of different robots are single-handedly contacting the server, so the task allocation becomes difficult, and then there would be a single point of failure. Let's suppose we have a 4 robots and all 4 robots are constantly contacting the server, and vice versa, a duplex communication. Let's suppose server fails due to any reason. Let's suppose a power failure happened. So the whole swarm would go into chaos and the swarm would ultimately not work. So the motivation was main while I was developing the Robo Soccer, like a robot for the Robo Soccer for the IIT Delhi Stress Challenge, where I was the only member and I had to control 3 different robots. So this actually sparked interest on to try different solutions. So the solution I came up was this, and it was mainly inspired by the military and the government institutes. Military in the sense how military structure is organized, like every role is divided, everything is decentralized, and decentralized in the sense there is one central authority, but that central authority has divided its work and those masters have divided his work. So that's how you do the effective work management. So this is the thing which I have modeled in MATLAB. So this is the system 1, this is the system 1, system 2, system 3. Here we have a priority table. Priority table is a requirement in our approach, and that same priority table would be shared across all of the robots in the swarm. Like here we are assuming that all different robots have different components connected, not same components. So different components would be having different priority. Here the least number indicates the highest priority, and here in our simulation, in our modeling, we have 5 different components, ranging from inertial measurement unit to ultrasonic sensor to GPS, infrared, and wheel encoder. System 1 has all the components connected. System 2 has components from ultrasonic to wheel encoder, and system 3 has components from infrared to wheel encoder. And here we have the main CPU, since it's a simulation, so I have put aside, since it would be a repeating block in every of the systems, so I have put aside and made it as a single block. Min max and a custom function, everything is open source. And here we have the status LEDs. First LED indicates whether it's master or slave. Second LED indicates whether it would be acting as a receiver, sorry, not receiver, whether it would be acting as a transmitter, acting transmitter, because master may not be the closest to the server, but there would be some other bot which would be the closest to the server. So while deciding the master, same 3 things would be decided: the potential master, in case the first the actual master, acting master, Second would be the transmitter. Which bot is closest to the server would be acting as the transmitter for that whole system. Like master would be, let's suppose this is the server, this is the whole server, and this is the master. So this master would be, this master won't be sending any request to the server. Instead, how it would be communicating, let's suppose this is as acting as a transmitter. So master would send details to this bot, and this bot would communicate with the server since it is closest. So that communication ping won't be high. So three things would be decided. First is master slave. Second is acting receiver. Third is potential master. Let's suppose this master fails. So then it would be then it has to be then the other bots has to immediately take the role of the master, which has been previously decided while deciding all these three. So let me show you the results also. So here we have the results. Once we have run the simulation, it's all being modeled in the MATLAB. So here we can see green, so it indicates that this system is the master. Here the yellow indicates this is acting as the acting transmitter, and the blue indicates in case this master fails, this system would be taking up the role as the next master. So that's how my proposed approach is very much dynamic in nature. It like my uh, when my approach is being followed, when the in the swarm, when one master fails, the whole swarm wouldn't be failing. There is no single point of failure. Immediately the next bot would be the taking up the role of the master. So the advantages of my system is the increased adaptability, decentralization, main thing, then the enhanced tolerance, improved scalability, because it can add n number of bots, it can subtract n number of bots also. So it doesn't, you don't have to reprogram each of the bot for the scalability purpose. It's all dynamic in nature, and it has also the potential for more complex behaviors, since you have actually have the all different roles divided dynamically, all decided by the robots. The applications could be in the search and rescue operation, whether it be in the mountainous areas or the flood areas, in the environmental monitoring, we have environmental monitoring with the UAVs, with the autonomous drones, then the construction, then the agriculture, then in the army also, where we are building the army of the bots, and we need to actually decentralize and have the proper role management. So this is our GitHub repo. Since everything is open sourced, so you can scan the QR code or go to the link which I have written down below, and you can contribute to the development. So our next future plan is to make a template or library, mainly in C++. You can mainly for the Arduino IDE for three different robots in a swarm, for three different robots, where one would have like everything, like what I have actually mentioned in the simulation, the systems which I have mentioned in the simulation for three different swarms, and then implement it actually on the actual hardware, on the actual robot, and then publish it to the world. So if possible, you may come and develop with me regarding this. You can scan the QR code and go to the GitHub repo also. Thank you. You may contact on my email or my mobile number for further queries regarding this topic. Thank you.